In today's lesson, we are going to talk about the derivative of polynomial function. First, I'm going to present all the rules governing the derivative of a polynomial function, and then later on we are going to prove each one of them. The first one says the derivative of a constant is always zero, which is obvious because a constant, the rate of change is zero for a constant value. The next rule says that if you have a monomial of the form x exponent n when n is a positive integer, then the derivative of the function is n times x exponent n minus 1. And another extension to this rule says that if you have a constant times a function, then the derivative of the function is constant times derivative of the function. The next rule is the sum rule, which says if you have the sum of two functions f and g, which both of them are differentiable, then the derivative of the sum of these two functions is if the sum of the derivatives of the functions. This means that if h of x is f of x plus g of x, then h prime is f prime plus g prime. The next rule says the difference rule, which says that if h of x is f of x minus g of x and both of them are differentiable, then h prime of x is f prime of x minus g prime of x. Now we are going to prove each one of these rules. So the first one is to prove the constant rule. So let's say that the function f of x is equal to c, a constant. We know that the derivative of f, which is f prime, is the limit of h goes to 0 of f of x plus h minus f of x divided by h, which is the same as limit of h goes to 0. But remember, f of x is c, there is no x involved, so if I change x to x plus h, the function becomes c again. And f of x is c divided by h, c over c is 0, and we know that limit of a constant is equal to the constant, which is 0. So this proves the constant rule. Now we are going to prove the power rule. So let's f of x to be x exponent n. Then f prime of x, by definition, is the limit when h goes to 0 of f of x plus h, which is x plus h exponent n, minus f of x, which is x exponent n, over x plus h minus x, which is going to give us h, which is the same as limit h goes to 0. But we can factor this one using the rule that we learned in the review for Unit 1 as x plus h minus x times x plus h exponent n minus 1 x exponent 0 plus x plus h exponent n minus 2 x exponent 1 plus up to x exponent n minus 1 divided by h. Now here x minus 1 cancels with x and minus x, they cancel each other, so we're going to end up with h, which is going to cancel with the h in the denominator. So this is equal to limit of h goes to 0 of x plus h exponent n minus 1 exponent 0 plus x plus h exponent n minus 2 x exponent 1 plus x exponent n minus 1. When h goes to 0, this becomes 0, this becomes 0, so we get x exponent n minus 1, x exponent 0 is 1. Then here we get x exponent n minus 2 times x exponent 1, which is x exponent n minus 1, and this all the way to again x exponent n minus 1. Now since there are n terms here, this means this is equal to nx exponent n minus 1. In the next example, f of x is square root of x, we have to show that f prime of x is equal to 1 over 2 square root of x. I can write f of x, which is square root of x, is exactly like x exponent 1 over 2. By the rule that we just proved previously, I can find the derivative is equal to, bring down the power, which is 1 over 2 x, and then subtract 1 from the power. This is going to give me 1 over 2 x exponent negative 1 over 2, which is the same as 2 x exponent 1 over 2, which is 1 over 2 square root of x. The next question says, verify this derivative graphically and numerically. Now, graphically, if we draw square root of x, we know that the domain is x greater than or equal to 0, because we can't have square root of negative number. When x is 0, y is 0. When x is 1, y is 1. So we get a point like this one. When x is 4, y is 2, which is going to be this one. And then the graph which represents square root of x is going to look like the following. Now let us plot f prime of x, which is 1 over 2 square root of x. When x is 0, you can see that 1 over 0 is going to give us infinity, so it's going to be somewhere around here when x is 0. When x is 1, here we are going to get 0.5. When x is 4, which is here, we are going to get 1 over 4, which is 0.25, very close to x-axis, so we're going to get a graph which looks like this. Now, if you look at the graph of square root of x, you can see that at x equal to 0, we do not have any derivative, because there is no left limit here at x equal to 0. There is right limit, which is 0, but there is no left limit. So limit doesn't exist. That's why your graph starts at infinity. And also, if you look at the graph of square root of x, you can see that it's going to continue and it almost becomes horizontal. And we know that the rate of change of a horizontal line is 0. So that's why as x goes to infinity, the derivative goes to 0. The next question says, evaluate dy over dx, which is the same as y prime, for each function. Express your answers using positive exponents. The first one, I can write that y is equal to x exponent 1 over 3, because x here is exponent 1, And then y prime is 1 over 3 x exponent 1 over 3 minus 1. Remember, x exponent n, the derivative is n exponent n minus 1. So y prime is going to be equal to 1 over 3x exponent negative 2 over 3. So I can write this one as 1 over 3 x exponent 2 over 3, which is 1 over 3 square root 3 of x squared. The next one, I can write this one as y is equal to x exponent negative 1. And then I can write y prime is negative 1 x exponent negative 1 minus 1. Y prime is negative 1 x exponent negative 2, which is negative 1 over x squared. And the last one, y is negative x exponent negative 5. And I can write this one as y prime is negative 1 times negative 5 times x exponent negative 5 minus 1, which is 5x exponent negative 6, which is the same as 5 over x exponent 6. The next question says differentiate each function naming the derivative rule that are being used. The first one is y is equal to 5x exponent 6 minus 4x cubed plus 6. Now when we get the derivative of 5x exponent 6, since we have a constant times a polynomial, is going to be constant times the derivative of that polynomial, which is x exponent 6. Now, we know that the x exponent 6, the derivative is 6 times x exponent 6 minus 1 minus, again the same thing, negative 4 is a constant, so it's going to be negative 4 times the derivative of x cubed is going to be 3 times x exponent 3 minus 1 plus 0, because the derivative of a constant is 0. Now 5 times 6 is 30, 6 minus 1 is 5, so it's 30 exponent 5. 4 times 3 is 12, so negative 12 x exponent 2 plus 0. So the answer is 30x exponent 5 minus 12x squared. The next one we have to do is the derivative of f of x is equal to negative 3x exponent 5 plus 8 square root of x minus 9.3. Now the derivative of negative 3x exponent 5 is negative 3, which is a constant, times the derivative of x exponent 5, which is going to be 5 times x exponent 5 minus 1 plus, remember x exponent, x times square root of x can be written as x exponent 1 over 2. So the derivative is 8, the constant, times, bring the exponent down, then subtract 1 from exponent, so 1 over 2 minus 1, and the derivative of a constant is 0. Now this one is negative 3 times 5 is negative 15, x exponent 5 minus 1 is 4, plus 8 over 2 is 4, so it's going to be 4x exponent negative 1 over 2. If you don't want to deal with negative exponent, I can write this one as negative 15 x exponent 4 plus 4 divided by x exponent 1 over 2, which is the same as negative 15 x exponent 4 plus 4 divided by square root of x. The next one we have to do is the derivative of g of x if g of x is 2x minus 3 times x plus 1. In this section, we haven't talked about how to find the derivative of the product of two functions. because 2x minus 3 can be one function and x plus 1 another. So the only thing we can do is just to expand this one. So I'm going to write g of x is equal to, so to expand it, I'm going to multiply 2x by x, which is 2x squared. 2x times 1 is 2x. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3, which is the same as 2x squared minus x minus 3. Now the derivative of this function is constant 2 times, bring the exponent down, so 2, and subtract 1 from exponent, 2 minus 1. And the derivative of negative x is negative 1, the constant, times, remember, the exponent here is 1, so bring the exponent down, and then subtract 1 from exponent, so 1 minus 1. Now 4 times 4, 2 times 2 is 4, so 4x, 2 minus 1 is 1, so 2x. Now minus 1, 1 minus 1 is 0, x exponent 0 is 1, so negative 1 times 1 is going to give me negative 1, so 4x minus 1. The last one is h of x, which is negative 8 x exponent 6 plus 8x squared divided by 4x exponent 5. We haven't talked about derivative of the ratio of the two functions, so this means that I have to get rid of the denominators. To do this one, I'm going to break the fraction into two parts. So I'm going to write negative 8x exponent 6 divided by 4x exponent 5 plus 8x exponent 2 divided by 4x exponent 5. Now this one and this one, they simplify, it gives me x exponent 1, which is x. Negative 8 divided by 4 is negative 2. So this is my h. Now 8 divided by 4 here gives me 2. X exponent 2 divided by x exponent 5 gives me x exponent negative 3. Now h prime becomes negative 2x exponent 1 is going to give me negative 2 is the constant times, remember the exponent is 1, so I'm going to bring the exponent down and then subtract 1 from exponent, plus 2 is the constant times negative 3 times x exponent negative 3 and then subtract 1. This becomes negative 2, x exponent 1 minus 1 is 0, which is 1. Negative 2 times 3 is negative 6, x exponent negative 4. Or I can write this one as negative 2 minus 6 over x exponent 4. The next example, we have to find the equation of the tangent to the curve f of x is 4x cubed plus 3x squared minus 5 at x equal to negative 1. First, let's find the coordinate of the point where the tangent line touches the curve. We know that the x is negative 1 and it has to satisfy the equation, so we just sub it back in this equation to get y. So from here I get f of negative 1 is 4 times negative 1 cubed plus 3 times negative 1 squared minus 5, which is negative 1 cubed is negative 1 times 4 is negative 4. Negative 1 squared is 1 times 3 is 3 minus 5 is going to give us negative 6. So the point is going to be negative 1 and negative 6. Now to find the tangent line, I need to find the slope. So I'm going to find f prime of x, which is going to be 4 times, again, bring the exponent down, and then subtract 1 from exponent, 3 times, bring the exponent down, so this is times x exponent 2 minus 1, and derivative of negative 5 is 0. This is going to give me 12x squared plus 6x. This is the equation representing the slope at any point on the curve. Now the point is negative 1 and negative 6. So f prime of negative 1 is 12 times negative 1 squared plus 6 times negative 1. Negative 1 squared is 1, so 12 minus 6 is 6. So this is my slope. So the equation of the line becomes mx plus b, which is going to be 6x plus b. To find the y-intercept, which is b, I'm going to use this point, which has to satisfy the equation of the line. So I'm going to say negative 6 has to be 6 times negative 1 plus b. This becomes negative 6 has to be negative 6 plus b. Negative 6 crosses out, so b is equal to 0. So this means the equation of the line is 6x. This is the equation of the tangent line. In the next example, we have a skydiver which jumps out of a plane from a height of 2200 meters. The equation which represents the height of the diver at any time t is given by h of t, which is given here, and the assumption is that the air resistance is not a factor. We have to find how fast is the skydiver falling after 4 seconds. Since the velocity, or let's put it, the speed is the rate of change of the height with respect to time, this means that we have to find the derivative of h with respect to t. So I'm going to say dh over dt, which is h prime, is equal to 2200, the derivative is 0, and negative 4.9 t squared. Negative 4.9 is the constant, times, bring the exponent down, and then subtract 1 from the exponent. So this becomes 9.8 t. Now we want dh over dt at t equal to 4, so I'm going to say h prime of 4 is negative 9.8 times 4, which is going to give me negative 39.2 meters per second. Negative represents that the height is decreasing and the speed of the diver is 39.2 meters per second. In the next example, we have to determine the points on the graph of y equal x squared times x plus 3 where the slope of the tangent is 24. So again, I'm going to expand y, so I'm going to get y is equal to x squared times x is x cubed plus 3x squared. I need to find the slope of the tangent, so I have to find the derivative of this function. So y prime is bring the exponent down and then subtract for 1 from the exponent plus 3 times bring the exponent down 2, subtract 1 from exponent. So I'm going to get 3x squared plus 6x. Now I want the derivative to be 24 because it says the slope of the tangent is 24, so this has to be 24. I'm going to bring this one to the left. I get 3x squared plus 6x minus 24 is equal to 0. I'm going to divide everything by 3. I'm going to get x squared plus 2x minus 8 is equal to 0. The coefficient is 1, so I'm going to use the sum product method. Looking for two numbers, the product is negative 8 and the sum is 2. Those two numbers are 4 and negative 2, so this is x plus 4, x minus 2 is equal to 0. So from here I get x is negative 4 and x is 2. Now I have to find the y coordinate because it wants the points here. So for x equal to 2, y becomes, I'm going to use the main formula, 2 cubed plus 3 times 2 squared. 2 cubed is 8, 2 squared is 4 times 3 is 12, so it's 20. So 1 point is 2 and 20. Now, when x is negative 4, y becomes negative 4 cubed plus 3 times negative 4 squared. Negative 4 cubed is negative 64. Negative 4 squared is 16 times 3 is 48. And negative 64 plus 48 is negative 16. So the next point is negative 4 and negative 16.